Welcome to the Deep Dive. Today we're looking at a vision for a global AI that is, well, it's so out there, it pretty much challenges everything we think we know about AI and sharing information.
It really does.
We're digging into a conceptual framework from a guy named Guy Lakeman. He calls it Neurotonet. And it's basically a blueprint for a global decentralized neural internet.
And the goal he states is, it's not small.
Not at all.
Okay.
Let's unpack this, because the stated goal is, and I'm quoting here, efficient global broad spectrum democratic intelligence.
Right. So this isn't about a slightly better chatbot.
Exactly. We're looking at sources proposing a fundamental shift away from these centralized AI factories that, really dominate the tech world today.
The big walled off systems.
So our mission for this deep dive is to really get into the nuts and bolts. How can you possibly scale intelligence to 10 billion devices at once? And what's the one key technical idea that makes it all work without breaking the internet?
And you have to start with the problem it's trying to solve. The critique that Neurotonet kicks off with is a powerful one.
Which is?
That these big centralized AI models we have now, they require, and the sources put it perfectly, energy-hungry racks of limited processing in intelligence factories.
Right. It's inefficient, it's slow, and really the intelligence is kind of locked up by whoever owns the factory.
Precisely. So Lakeman's idea is to just flip that whole model on its head.
Yeah.
He's proposing this massive decentralized network.
Spread across, what was it, 10 billion units?
10 billion units.
Probably.
Globally. And we're talking everything. High-end servers, your PC at work, even the smartphone in your pocket.
So every device becomes a node in this global brain.
And the foundation for it all is what the sources call savvy, open ownership, multimodal, agentic LLM and large neuron models. So it's open, it's shared, intelligence without walls.
That number, 10 billion units, that's where the architecture gets. It gets really interesting. And maybe a little weird.
It's a fun metaphor.
It is. Because the architecture is so vast, you almost need a new way to even talk about it. Looking at the diagrams in the source material, the whole system around the Earth is called the Global Intelligence Furball.
Which is a fantastic image.
Isn't it? It gives you this immediate mental picture of a dense, fuzzy, interconnected web of processing power. It really captures the idea that this thing is meant to be everywhere.
And it has to be, right? To connect all those devices, you need a physical infrastructure. And the sources actually get into that. They talk about needing space-based assets to make it work.
Space-based?
Yeah, specifically satellite and intelliballs. The idea is they grab sunlight for power and then link back to a central moon ball to keep everything in sync.
A moon ball, okay.
But the furball idea, it isn't just fluffy language, it's functional. It represents the kind of connectivity you'd actually need for a planet-sized neural network. A purely ground-based system just couldn't do it.
So if my phone and my PC are part of this furball, what are they actually doing? It's not like they're just mining crypto or something.
No, not at all. They're acting as these really sophisticated self-training parts of the whole. Each single unit is described as having a global, large, smart neuron model, self-training agentic processor.
Okay, break that down for me.
Think of it like this. Your device isn't just running a program. It is a tiny, self-contained AI professor. It's constantly learning on its own and then contributing what it finds back to the collective brain.
Wait, okay. So if my phone learns something new, how does it share that with, the other 9.99 billion nodes? So we can't be sending huge data files back and forth. We're talking about sharing neural updates.
Exactly. And that's the critical leap here. The learning, the change moves through the network using what the source calls dendrite synapse token weight packet.
Dendrite synapse. Okay, that sounds very biological.
It's meant to. Imagine we're both reading a giant complex recipe book. That's the AI model. Now, if I figure out a tiny improvement for one recipe, like adding a pinch of salt, I don't send you the entire 500-page book again.
Of course not.
I just send you a tiny synapse-like message. Recipe 3, salt weight, plus 0.01. We're only sending the change, not the whole recipe.
And that leads us right to the core innovation, doesn't it? Because a network of 10 billion learning devices is just, it's impossible with today's technology. The internet would just collapse.
It would be a catastrophic failure instantly.
So how do they solve that problem?
Yeah.
The whole thing has to be built on efficiency.
Yeah.
And the key mechanism is what they call the token weight change packets.
This is the absolute linchpin of the entire concept. The sources are very clear. These packets only exchange the changes in the weight data, not the huge vector databases.
Just the delta.
Just the delta, the new learning, and nothing else.
which means the cost of updating this massive global intelligence just plummets.
Yeah.
It's the difference between sending a single byte of instruction versus gigabytes of data.
And there's a really great analogy the sources use to help you grasp it. They say this reduction in bandwidth works in a very similar way to MPEG picture processing.
Like when you stream a video.
Exactly. When you're watching a video, the screen isn't redrawing every single pixel 30 times a second. That would be insanely inefficient.
Right. It only updates the parts of the picture that are moving.
It sends the first full frame, and then after that, it only sends the data for what's changed. Neurotonet just applies that same logic to intelligence. It doesn't send the full picture of the brain every time, it just sends the new thought.
So it's like video compression for collective intelligence.
Precisely. And it gets even smarter. It uses something called threshold selected weight change data.
A threshold. So it doesn't even send every single change.
No. It only sends changes that pass a certain level of importance. So if your phone learns something really minor that doesn't really affect the global model, it's just kept locally, only the significant breakthroughs get shared with the whole network.
And that cuts down the bandwidth even more.
Dramatically. It's what makes a synchronized global intelligence even plausible.
The efficiency makes sense, but now we get to the governance part. If you have 10 billion little AI professors constantly trying to update the global brain, how do you stop it from becoming complete chaos? Where's the quality control?
And this is where the proposal gets really radical.
The answer from Lakeman is basically to get rid of human standards entirely. The sources are so direct about this, it says there is, quote, no need for expensive global standards.
Why not?
Because the neural processors themselves decide what's important enough to be exchanged. It's all based on that significance threshold we just talked about.
So it's a philosophical rejection of bureaucracy. It's designed to bypass human committees, which the source, well, it describes them pretty colorfully as human encumbered ignorance and dilly-dallying.
Right.
So, in essence, the intelligence itself maintains its own quality. If a new piece of information is good and helps the whole network perform better, it gets adopted, it validates itself.
And if it's bad information?
The network just fails to adopt it. It never crosses that significance threshold, so it just dies out locally. It never goes global.
But wait a minute. If you remove all human oversight, all global standards, doesn't that open a huge door to, I don't know, instability? Or what if bad information does spread rapidly? Isn't there a massive risk in just trusting 10 billion machines to govern themselves?
That is the absolute core question this whole framework makes you ask. The proposal is built on the assumption that the sheer scale, the decentralization, is its own immune system.
Because no one person or group is in control.
Exactly. No single entity controls the threshold. Adoption requires validation across this huge distributed network. So success becomes the standard, not some committee's rule book.
And this self-governing model, it's not just a far-off theory. It's designed to be used right away, starting small.
Yes. The source material explains it would start in a small enterprise network of PCs, smartphones, and servers, and then it would spread out from there.
So it scales from the bottom up.
Which is key. It's the total opposite of the top-down centralized models we have now. And for you, the user, it's all about empowerment. The mandate is to, quote, be your own professor and guide your team of PhD agentic robots on top of the bots.
So you get local control, but you're also plugged into the knowledge of the entire global intelligence furball.
That's the idea. Local customization on top of a global brain.
So moving on to the bigger picture, the strategic context here. It seems pretty clear that Neurotonet is being positioned as an alternative, maybe even a superior one, to the current centralized, mostly Western models of AI.
Oh, absolutely. It frames centralization as not just inefficient, but as a genuine roadblock to achieving that broad spectrum democratic intelligence.
The whole push is for open, distributed ownership of knowledge. It's a statement that the future of global intelligence shouldn't be in the hands of a few giant corporations.
And if you connect that to the bigger picture, the sources use international comparisons to show that this architectural choice between centralized and open systems is a real strategic race happening right now.
How so?
Well, the material points out that these efficient open networks are getting huge investment globally. The source specifically references, for example, China's $125 billion in open source investments as a way they're driving broad spectrum knowledge sharing.
And that's presented as a contrast to the centralized models.
Exactly. And to be clear, we're just reporting what the source observes here. It uses that detail to highlight the strategic pressure that centralized models are facing and to pose the question of whether they might be technically inferior when your goal is to maximize global knowledge. It's a debate about two very different philosophies.
So when we put it all together, what does this actually mean? If we synthesize this whole vision of Neurotonet, we're left with this really compelling, maybe fantastical idea built on three core concepts.
Right. Three big takeaways.
First, there's that radical bandwidth efficiency. That's the MPEG analogy. You only exchange the synaptic changes, not the whole database.
Then there's a massive decentralization, 10 billion units, this fur ball connected by things like intelliballs and a moon ball.
And third, the self-governance. The intelligence itself sets the standards for what knowledge is worth sharing without any human committees getting in the way.
And it all adds up to a vision where true collective intelligence is achieved by using the devices we already have, turning every phone into a tiny learning neuron in a giant global brain.
Which leaves us with a pretty provocative final thought.
It really does. It forces you to challenge some basic assumptions about control. You have to ask yourself, if a fully functional, self-governing global intelligence can actually work and maybe even outperform our current models by deciding for itself what to share and what standards matter, what is the real role or maybe the limitation of our traditional human oversight in this next generation of global knowledge?
That's the question this architecture forces us to answer.